Hello. Today we're going to talk about electric current. Okay. Before that, we're going to talk about battery. So just a simple battery. We're going to call this one here positive, for example. So that's a positive terminal. Terminal 中文叫终端。So this is also called positive electro. Okay. So electro 就是电极的意思，电极。And so this is positive electron, and this side is negative, so it's a negative electron, right? And inside here, it's normally called electrolyte, 电解质, right? Okay, and this side is called negative terminal also, right? So terminal. So the symbol, it's usually like that. So positive is a long one, negative is like that. Okay, second symbol I want to introduce is ground. So ground is like earth, or like if you're a car, the body of the car is the ground. So it's like a big piece of something. And so the ground has a lot of positive, has a lot of negative, right? So lots of them. So it's kind of like a reservoir. Okay. So if you take out one electron, it doesn't really reduce, there's no obvious change to the ground. And then we're going to also give you the symbol of resistance now. Resistor, okay? So 电阻. All right. And with that, we're going to start talking about the Ohm's law. So Ohm's law, 欧姆定律, right? Ohm's law says the following: V is equal to IR. Okay. So R is the resistor symbol. So this is resistance. And the unit is ohm, or OHM. And I, it's for electric current. So electric current, it's for the positive current. So it's like positive current. So this is an early mistake by scientists. They think that the positive is the one that's moving. So this turns out to be incorrect. So it should be an electron flow instead. So electron flow will be a negative, right? Will be a negative current, or negative, you know. And this is the voltage. So this is the electric potential that we talked about in earlier chapter. Electric potential. So the unit is volts, V-O-L-T-S, okay? And for the current, the unit is A or M, A-M-P, ampere, M-P-E-R-E. Or sometimes people say M, A-M-P, okay? Okay, all right, so I'm going to erase and I'm going to continue talking about the ohmic material. So ohmic material means that if you have current is right here and your voltage is right there, and it's a straight line that crosses the origin. And so this type of material, it's called ohmic material. So R, it's equal to, you can see V is equal to IR. So the R here is the inverse of the slope. Right? Or slope is equal to 1 over R. So when R is constant, right, independent of what V you have, right? The V, what independent of V, right? What's the value of V? So this is V, not small v. Okay. So when your voltage is changing, the slope remains the same. That means your R is constant when the V is changing. So that it's called ohmic material, OHMIC. Okay. So non-ohmic material usually behave like not a straight line. Instead, it's maybe something like that, right? Or it could be some other pattern, some other type of curve. But this is non-ohmic. This is non-ohmic material. Sorry. Okay. So a lot of time we treat metal, right? We treat metal, most of metal, it behaving like ohmic material. Okay. Most of metal, right? But not all of them. So to this, right? So you can see V equal to IR is not universal, right? This is not a universal law like the UGL, like universal gravitational law, right? This is not universal. Instead, it's an empirical. Empirical law that only apply to certain material, right? Only apply to the ohmic material, right? Okay, and also, if the temperature change too much, this may not be true, right? So temperature need to be bounded, right? Bounded, right? For this to be true, okay? All right, so this ohmic and non-ohmic material, okay? What else can we talk about? Yeah, so let's talk about current, right? So what's current? So current, the symbol is I, and the unit it's M, like we say, and it's defined as the delta Q, which is the charge, right? This is charge. The unit is coulomb, right? And then delta T, and this is time, right? So what does that mean? If you have a wire, and let's say the delta T time is right about there, okay? And if we go and count the amount of electron that goes through here, right? You count them up, and you say, okay, so how many electrons do I have, right? And E times electrons charge, which is 1.6 times 10 to the negative 19, right? So not this, but number of electrons, right? So let's say there's a 10 to the 10, right? This many electrons, and times 1.6 times 10 to the negative 19, okay? And let's say this is 1 second, for example. In 1 second, and this many electron pass, need by 1 second. So you can see that means this. That means 1.6 times 10 to the negative 9, okay, M. Okay, so this is coulomb. So this is coulomb divided by second, which is equal to M. So that's the definition of current. It's in the cross-section within a certain amount of time, how much coulomb or how many coulomb has passed, right? Okay, so I think that's the part that we want to talk about. Yeah, there's one more thing, which is the color code. Okay, so for resistor, it's often color coded like this. It has 4 rings. So on one side from the top, let's say this is red. I'm going to change it to red. Red, okay? And let's say the second one is green. So make that green. And then the third one, let's make it to, what's the example here? Let's make it to yellow, okay? Make it yellow. Yellow. And the last one, let's make it silver. I don't have silver, so I'm going to pretend I have a silver here. and the silver. Okay, this is my pretend silver. Okay, this is my silver here. Okay, so the first two is so-called the first and second digit. Second digit, okay? So what does that mean? So if you go look up, right? And then red means 2, okay? And green means 5, right? Red is 2 and green is 5. So then this one here then says that it's 25, okay? And this yellow is a multiplier. So this yellow is a multiplier. So it's a power multiplier. So it's a power. So times 10 of the yellow, and the yellow is 4. So times 4. So that's the resistance. It's 25 times 10 to the 4 ohm. And silver is the tolerance of the resistor. So this yellow here, the silver here is -2. Silver is -2. So this is 10 to the -2. It's your tolerance. Okay, so how precise is your resistance? Okay, so that's the resistance color code, right? Resistors color code. So that's how you tell what's the resistor, or resistance value. Okay, so that's all we have today, and have a good one.